Today's lesson is about the perpendicularity of a line in a plane. So two objectives we're going to take a look at here is be able to recognize when a line is perpendicular to a plane, so when is that true, and then two, apply the basic theorem concerning the perpendicularity of a line in a plane. So if you actually know then that a line is perpendicular to a plane, what can you conclude from there? Okay, so let's start by going over a definition here. And this is the definition for what it means for a line to be perpendicular to a plane. So it says if a line is perpendicular to a plane, if it is perpendicular to every one of the lines in the plane that pass through its foot. Okay, so there are two types in general of perpendicular. We can talk about two lines being perpendicular, and then we can also talk, like I said, today's lesson is about a line and a plane being perpendicular. So just kind of referring to this picture here a second, if two lines are perpendicular, it would look like line DF is perpendicular to FC. If you're trying to say a line is perpendicular to a plane, you would say the line DF is perpendicular to a plane, in this case plane M. Now remember from the previous lesson, we name a plane with a lowercase letter usually written in the corner. Okay, so if I look at this particular example, it says, like I said, line DF is perpendicular to plane M. And my conclusion is line AF is perpendicular to what? So again, in general, we said if a line is perpendicular to a plane, it's perpendicular to every line in the plane that passed through the foot. So in this particular picture, line DF intersects plane M at point F here. So therefore, line DF is perpendicular to every line in the plane that actually goes through F. Okay, so in this case, line AF would be perpendicular to line DF, because AF obviously has an F in it. Didn't ask you this question, but like line DF would be perpendicular to line FB. Line DF would also be perpendicular to line FC. Any line that goes through F that lies in the plane, DF is perpendicular to it. Okay, now this next particular theorem is talking about what you need to know in order to state that a line and a plane are perpendicular. So if a line is perpendicular to two distinct lines that line a plane and pass through its foot, then it's perpendicular to the plane. So key number here is 2. Oops, sorry about that. So to prove that a line is perpendicular to a plane, you need two distinct lines that line the plane and pass through the foot. One is not good enough. You actually need two, I guess, or more, you should say. So if I look at my picture here on the right, if we are given that line BF and line CF lie in plane M, and we know that AF is perpendicular to line FB, and AF is perpendicular to line FC, so what can we conclude? Notice it's perpendicular to two lines in the plane that pass through the foot, which is F. So we could conclude then that line AF is perpendicular to plane M, because again, we had two lines. We had these two here. Okay, you need two, at least two, to prove that a line is perpendicular to a plane. Again, you need at least two. So if I look at this example, it says if angle RHT is a right angle, can we conclude that line TH is perpendicular to plane M? And it says why or why not? So again, we just talked about how many do you need? You need two. And in this particular picture, how many do we have? We only have one. So my answer is going to be no. And just going through it, it says why or why not. So no, because like I was just saying, we need two distinct lines. That lie in plane M and pass through its foot, which in this case is point H. So again, it's a no, because again, this only told us if RHT is a right angle, then we can conclude that line RH is perpendicular to line TH. That's one. But again, we need two distinct lines that lie in plane N and pass through the foot, which is point H. And notice in the picture, there's actually only one drawn in. Okay, so if we look at our last example, it says if ABCD is a square that lies in plane T and line PF is perpendicular to plane T, how many right angles can be found in the picture? Okay, so this one's a little deceiving here. If you count it, since ABCD is a square has, oh, that looks messy there, let's try that again. A square has 4 right angles at the corner, and in the diagonals, remember, of a square are perpendicular, so I've got another 4. So again, I've got 4 in the corners, I've got 4 at the diagonals, and then if the line is perpendicular to the plane, it's perpendicular to every line in the plane that passed through the foot. So notice there are going to be 4 right angles coming in with the line perpendicular to the plane. So with the line perpendicular to the plane, that gives me another 4. So 4, 4, and 4 make a total of 12. So again, if you're confused about the line perpendicular to the plane concept, again, my right angles would be AFC, AFB, AFA, and AFD. Those would be those 4. Okay.